Sam? You're really good. You just believe me? Okay. Well, we're talking about double angle formulas today. So a double angle is like, if I say cosine of 2a or 2 theta. This is really no different than a sum or difference formula because 2a isn't that the same as a plus a. So technically you wouldn't have to have these formulas. You could use the sum and difference formulas that we already have. But this is where they come from, and actually all my proofs use the sum formula. So I will give these to you if you want to go to your flip chart. We're on the final page, double angle formulas. And these are the only ones on there. You will notice there are actually 3 options for cosine 2a. All 3 of them work. They're all equivalent. You could pick whichever one you liked, but then we only have 1 for sine and tangent. Understand this. Again, these formulas are given to you. The only ones you have to know are on that first tab. Are reciprocals, you know, that tangent is sine over cosine and so forth. The rest are given on the formula sheet. So if I gave you this problem, find, or given that sine of theta is 2/5 and cosine theta is less than 0. I want sine, cosine, and tangent of 2 theta. Sine 2 theta is 2 sine theta cosine theta. That's our formula. I have the sine of theta, but did I give you cosine of theta? No. So what we're going to do is come back up here to this. This is something that we would have had like in chapter 1 or chapter 2, when we had one value and we had to find the others. Think back. We could use an identity, but it's probably faster just to do it with a triangle. Sine is a positive number, but cosine is negative. Which quadrant would I be in? Quadrant 2. So if we draw a triangle, we know sine is opposite over hypotenuse. So how would you find your missing side? Okay, when you ask for you need plus or minus, that's why the quadrant's important. Since it's quadrant 2, you're going backwards, so your x would be a negative. So this is negative radical 21. Now, I can't just use this triangle to answer the questions because I want sine of 2 theta, and this is the triangle for theta. But now I can find cosine of theta from my triangle. Cosine adjacent over hypotenuse. Negative radical 21 over 5. So if I multiply, I get negative 4 radical 21 over 25. All right, for cosine 2 theta. We have 3 formulas. It does not matter which of the 3 you use, you will get there. Now, the original problem gave us sine, so if I wanted, I could pick the formula that only has sine in it. If I did one of the others, I have to find cosine, but I already set up my triangle, so that's no problem. We've already done that. So you pick whichever one you want to use. I'll go with the 1 minus 2 sine squared theta. Okay, Remember, sine squared means you take the value of sine and square it. Sine of theta in my original problem told me was 2/5. So if we square that, multiply by 2. And we get negative 17 over 25. If you did one of the other two formulas, you would get the same thing. All right. So far, so good? Mm-hmm.
Would it be positive 17 over 25?
Oh, yes, it is. Thank you. 1 minus that should be positive. All right, tangent. We have two ways of getting that. I can use my tangent formula, okay? And that will work perfectly. We also know, yeah, would it be easier to do that formula or sine over cosine? Sine over cosine. You just have to remember, if you're doing tangent of 2 theta, you have to do sine of 2 theta divided by cosine of 2 theta. All right, so my sine 2 theta I found first. Negative 4 radical 21 over 25. Cosine was 17 over 25. How do we divide fractions? 25's drop and we get negative 4 radical 21 over 17. So we have to set up a triangle at the beginning so that we could use our sine formula. And then from there, it's just a matter of plugging into our formulas. Just be very careful. Make sure you're paying attention to 2 theta versus theta. Okay, they're different angles. How do we feel about that one? I have example B and C, just like it. Do we need to do another one? Maybe one more? Let's go to this one. Okay. This time I gave you tangent. Tangent is a positive, but sine is negative. So which quadrant? Okay, tangent is opposite over adjacent. What's wrong with those numbers? I went left and down. Yeah. The reason it didn't have negative is 2 negatives made a positive, right? But when I set up my triangle, they would be negative. We have negative 5 squared. It's negative 3 squared equals c squared. Hypotenuse is always positive, so we get radical 34. Reduce that if possible. 34 doesn't break down. All right, sine 2x. There's only one formula option. It's 2 sine x cosine x. So from my triangle, what is the sine of x? Opposite over hypotenuse. So negative 5 over radical 34. Okay, we could move the radical, but I'm going to wait just a minute. Cosine would be what from this triangle? So that would give me negative 3 over radical 34. that gives me 30 over 34, or 15 over 17. All right. Cosine. 3 formula options. Does not matter which one I pick. Give me one. Which one do you want me to use? Same one I did last time? 1 minus 2 sine opposite over hypotenuse, so -5 over radical 34 squared. So if I square that, multiply by 2, so 1 minus 25 over 17. -8 over 17. I didn't ask for tangent this time, but if I did, all you have to do is sine divided by cosine or the tangent formula. All right. Questions on that one? Let's look at another problem. All right, what did I change? What I'm finding, instead of finding values of 2 theta, I'm asking for values of theta, right? We have all of these formulas. What I gave you was cosine of 2 theta. Now there are 3 different formulas for cosine 2 theta. If I want to find sine or cosine, all I have to do is pick one of these formulas to start with. And there's really only one that wouldn't work for me here. And that would be if I pick this one, because can I solve for cosine and sine at the same time? No. So I need to start with one of the other 2. So let's go with this one. I haven't used that one yet. So that is 2 cosine squared theta minus 1. I have cosine of 2 theta, so that goes in my cosine 2 theta. What would I need to do now if I'm trying to find cosine theta? Add over the 1. And then we can divide by 2. All right, how do you get rid of a square? With it, we have plus or minus. How do I decide if it's positive or negative? If you're between 180 and 270, that's quadrant 3. And quadrant 3 is cosine positive or negative. We have negative radical 7. 8 would reduce to 2 radical 2. So it's negative radical 14 over 4 if you multiply the square root of 2 on top and bottom. All right. I asked for the sig-trig functions. Could I keep using these formulas to find all of them? Yes. Is that necessary? No. Once you have one of them, what could you do? We can think back to x, y, and r. We can draw a triangle. Most of you, I think, typically go to triangles. We already know that it's in quadrant 3. Cosine's adjacent over hypotenuse. Square root plus or minus, which one would this be? Positive or negative? Negative. Are you guys all with me there? So now can you tell me what sine of theta would be? Opposite over hypotenuse. Reciprocal of sine cosecant, you just flip that. Multiply square root of 2 on top and bottom. Do I get a negative? I already have cosine. Reciprocal of cosine is secant. And multiply my radical on top and bottom. There's a lot to this problem, but a lot of it's stuff we've done. Okay, the triangle, the sixth-degree function, we were doing that at the very beginning. So I have sine, cosecant, cosine, secant. What is tangent? Sine over cosine or opposite over hypotenuse? Sorry, opposite over adjacent. I pointed at adjacent and said hypotenuse. So if I reduce that, I get 1 over the square root of 7, or radical 7 over 7. And then cotangent, adjacent over opposite, it's just the square root of 7. All right, so really what we're learning here is all we need is one piece, and then we can find everything. Ultimately, if you know one trig function, you can draw a triangle and find all of them. Okay. Any questions on that? Let's do a proof. Which side would you box in? Okay. Thoughts on what I could do first? Okay. Cosine to the 4th will break into cosine squared beta. Difference of squares, one is positive and one is negative. So cosine squared beta plus sine squared beta. Cosine squared beta minus sine squared beta. What is cosine squared plus sine squared? 1. Times cosine squared minus sine squared. What is cosine squared minus sine squared? That's the first double angle formula. Gotta get cosine 2. So same formula, same process with proofs, just you have more formulas to work with now. Do we need another one like this? Let's do one final slide. I think I'm going to jump. you to simplify this. We don't know the sine of 22.5 degrees. But what formula does this look like?
Cosine 2A.
This is 1 minus 2 sine squared A. So that is the cosine 2A formula. A is just the angle. What's my angle here? So 2 times 22.5 is 45 degrees. What's the cosine of 45? So I could give you the right-hand side of the formula as well. What if I gave you this one? What does that look like? This is cosine squared A minus sine squared A. That's the cosine of 2A formula. My A is 5 pi over 6. So 2 times that is 5 pi over 3. What quadrant is 5 pi over 3 in? 4. Reference angle, pi over 3 is like 60 degrees. In quadrant 4, cosine is positive, the cosine is 60.